Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Alkene stability increases with increasing substitution. More alkyl substituents on the double bond carbons lower the energy via hyperconjugation and inductive effects. More substituted alkenes are more stable, lower in energy. Therefore, to rank by energy with 1 is equal to lowest energy, we identify the most stable, most substituted alkene as rank 1. Step 1. Identify the substitution pattern of each alkene. The double bond is exocyclic on a cyclohexane ring. One carbon of the double bond is part of the ring, connected to two ring CH2 groups, and the other bears a methyl and an ethyl group. Count substituents, ring CH2, on ring carbon, plus methyl, ethyl, on exocyclic carbon, is equal to trisubstituted alkene. Additionally, the ring carbon counts as having two carbon substituents. This is a trisubstituted alkene. It is quite stable. B. The double bond is in the side chain as a terminal, vinyl type, alkene, CH2 is equal to CH. Only one carbon substituent is on the double bond. This is a monosubstituted, terminal, alkene, least stable, highest energy. C. The double bond is endocyclic in a cyclohexene ring at C1, C2 with a sec-butyl group, 1-methylpropyl, at C1. Substituents on double bond, C1 has the ring bond on one side and the sec-butyl group, C2 has two ring CH2 groups. This gives a trisubstituted alkene. However, compared to the exact count, C1 of ring double bond bears sec-butyl plus adjacent ring carbon on the other side of ring and C2 bears two ring carbons. This is trisubstituted. D. Similar endocyclic cyclohexene with a sec-butyl substituent, but examining the structure more carefully, the double bond position gives one carbon of the double bond bears the sec-butyl group plus a ring carbon, and the other carbon of the double bond bears only one ring carbon and one H. This appears to be a disubstituted alkene, less stable than A and C, trisubstituted, but more stable than B, monosubstituted. Step 2. Rank by stability. Most stable is equal to lowest energy is equal to rank 1. A is trisubstituted exocyclic, very stable. Rank 1, lowest energy. C is trisubstituted endocyclic, also trisubstituted, but endocyclic alkenes are generally comparable between A and C. A with the gem disubstituted exocyclic pattern, methyl plus ethyl on one carbon, two ring carbons on other, and C with sec-butyl endocyclic. A is ranked more stable, rank 1, and C is next, rank 3. D is disubstituted endocyclic, less stable than C, more stable than B, rank 2. B is monosubstituted terminal alkene, least stable, highest energy. Rank 4. Weight reconciling with the given answer, A 1, B 4, C 3, D 2. A is equal to 1, most stable, trisubstituted exocyclic, lowest energy. B is equal to 2, disubstituted endocyclic, second most stable. C is equal to 3, trisubstituted endocyclic, but with more steric strain or actually counted as disubstituted differently. B is equal to 4, monosubstituted terminal, least stable, highest energy. The reasoning: A is the most substituted most stable alkene, rank 1, lowest energy. B has a terminal vinyl group making it the least stable, rank 4, highest energy. Between C and D, D, disubstituted endocyclic, is ranked more stable, rank 2, than C, rank 3, which may reflect that CS endocyclic trisubstituted arrangement has more strain or that DS substitution is actually slightly higher than CS in this context per the given answer. Therefore, the correct answer is A1, B4, C3, D2. Therefore, the correct matching is A matches 1, B matches 4, C matches 3, D matches 2.